Integration by substitution, also known as change of variable. Example 4, this time we have limits of integration. So the method is similar to before, but we're not going to undo the substitution at the end. Okay, so we have everything in terms of x, and the limits are x equals 0, x equals 2. So the limits are also in terms of x. Okay, so x is u minus 1 there. The x plus 1 in the brackets is u, so that's u cubed. U is equal to x plus 1, so du by dx is equal to 1. Take the dx, multiply it with the 1, so we have dx is equal to du. We need to modify these limits from x equals 2 and x equals 0 to u limits. So x equals 2 from this one. Substitute in here, so we replace this with 3. For this limit here, we've got x is equal to 0, substitute 0 into here, so then we've got u is equal to 0 plus 1, so u is equal to 1 here. So now we have everything in terms of u. Expand the brackets, integrate. So now we don't have to undo the substitution. We stick with the new limits, because everything here is in terms of u. We substitute the values in and we get the final answer. Example 5. So again we have limits, so we're going to change everything here from x, because that's x equals a half pi, that's x equals 0. We're going to change everything from x to u. So I need to put this limit here, half pi, into there, so you've got 1 plus sine half pi, like this, which gives 2. So u is equal to 2, so the new limit there will be 2. Then we do the same with x equals 0. Start with x equals 0, substitute into here, and then we've got u is equal to 1. So for the dx, we start with our substitution, we differentiate du by dx, and then we rearrange this to make dx the subject. So we're going to replace the dx there with 1 over cos x times du. Okay, so substituting everything in that we have so far, so the new limits are here. I haven't done anything with the cos x at the moment, that's still cos x. And the square root of 1 plus sine x is just u to the power of a half. And the dx there, well, that was 1 over cos x times du. I've got that here. That cos x and that cos x, because that's in the denominator, they cancel. So everything simplifies. We now do the integration. That's done. Substitute the limits in, and here's our final answer. There's no plus c this time, because we have limits of integration. There are 3 more problems here. The first one, you're integrating this function using this substitution, and you have to show this is the final answer. Okay, second one, you've got limits of integration, and this is the substitution that you're going to use. And in the third one, you have to show that you can rewrite this using this substitution in this form, and then show that once you've integrated, you get this, where k is a constant. I'm going to rush through the solutions, so pause the video as needed. For further practice, try these questions.